Number one, does it make sense that G is the rate in? Great. Now, remember we said this. Sometimes they give you the rate of change total, not a rate in, rate out. But this is a rate in, rate out problem. They're not all rate in, rate out problems. Okay? You know this is a rate in because it says at which it arrives is this. So it's not how much is going out. Okay? They could also just say the rate of change of gravel in the plant is this. And then that's just a total combined, rate in and rate out. Okay? They also tell you, and you got to read this carefully because I know it's easy to miss. They tell you at the beginning of the day there are 500 tons. That allows us to find how much there is at any other time, as long as we know the total rate of change. Okay? And they tell us the rate at which it exits is just 100 tons per hour. Okay? So, that right there, just hearing you say that over there is a very common thing. I keep telling you, read this whole thing. Make sure you understand what they're telling you. Okay? Otherwise, it's going to make these questions like impossible. But anyway, A just says find G prime of 5. You have a calculator. You should put G into your calculator. Okay? I did in Y1. There it is right there. Cool. And then all I'm going to do is math 8. Math 8. I'm going to say derive. Whoops. Y1. Right? At 5. Negative 24.588. Negative 24.588 equals, that is G prime of 5. We need some units on there. You don't have to show any work. Now, you have a calculator. Just show, hey, G prime of 5 is this. Okay? Say what you did. If you integrated something, write down the integral you did. If you derived it, write down G prime. You don't have to show any work. You should be able to derive that by hand, but it doesn't matter if you can or not at this point. Okay? The units on G are in, what's it say? In tons per hour. So the units on G prime are tons per hour squared. Tons per hour per hour. It's the rate of change of the rate of change. Then it says interpret it, okay? I'm going to type it just because my handwriting has been abysmal. Well, just is abysmal, I guess I'm going. Ready? At T equals 5 hours, all you got to do is put what G is and say the rate of change of that, okay? The rate of change of, see what they say G is? The rate at which unprocessed gravel arrives? Of the rate at which unprocessed gravel arrives at the plant is doing what? Decreasing at 24.588 tons per hour squared. That's A, my friend. I'm explaining what that number means. That's all you got to say. Yo.
Yeah, that answer is C.
It's not C. And we'll talk about why. Guys, G prime is the rate at which the rate changes. C is asking about the maximum amount. You got to read these carefully to understand what function they're actually asking you about.
C is not asking that.
Yeah, the amount increasing or decreasing. It has nothing to do with G prime. What do you mean? Oh, sorry, with D. D says max. But whatever, okay, sorry. But either way, it has nothing to do with G prime. Okay? Don't second guess me. I demand respect. Okay. Anyway. That should not have been a hard question at this point. All right? You find the derivative, you got a calculator, that's it. Bam. B. Find the total amount of unprocessed gravel that arrives. Well, now we just care about how much came in. So we're going to do the integral during what? Hours of operation of the day? So it's 0 to 8, right? 0 to 8, just G of T, since that's the rate at which it arrives. This is going to tell us how much has arrived. I'm just going to use my handy-dandy calculator. Okay. If my computer So what do you think is happening right now? Something's wrong. The computer's frozen. Let's see. Do you see a mouse? Typing. Great. Okay, that did something. Why is it stuck like this? What is this? There we go. There we go. Man, oh man. Yeah, open up. What is this, Math 9? 0 to 8. Did you guys do this? This was an easy one. Kaboom. With respect to x, it's going to spit out a number. Does it say to the nearest anything, or just says how much? So 825.551. What are the units on that? Tons. So, that's a great question. We don't have to add 500 because it doesn't ask how much is there, it asks how much came in. Okay, the 500 was already there. Everyone understand that? The 500 is only used if they're asking you for the amount of gravel left at that plant. And they're not. They're asking how much arrived. Okay? Is that all they want? That's it. Just put tons on there and you're done. Okay? C. Is the amount of unprocessed gravel at the plant increasing or decreasing? Here's what I keep telling you about this A of T thing. Okay? And a lot of y'all, for some reason, did not do this on the test. Okay? I said you can make up an amount function. You don't have to. You can just say, is G of T bigger than or less than 100, right? But if I were you, I would say A of T is the amount of gravel at the plant at time T. Okay? That's what A of T is going to be. Then I'm going to build the function. A of T has to equal the amount that was there, that we know, plus the change, which is the integral of the rate in minus the rate out, which is G of T minus, what was it, 100? That's A of T. What's up, man? Hey, look at these old boys coming in here. There's more? Get out of here. All right. Come on in. We're doing calculus. All right. Yo, the benefit of this, kids, the benefit of this is that we get to now talk about the rate of change of the amount, which is what they asked us about. We can say A prime of T is just, oh, I messed up. One thing. They should be x's. You guys see that? A prime of T is G of T minus 100. They want A prime of what time? At 5, right? So this has nothing to do with that derivative there. A prime of 5. No. So, 100 an hour, if you integrate that to get 100t, that's what you're doing. That's the amount that is left. 100t is how much is left. You're integrating it already. Okay? So we need to know what this is. You can do it in a calculator. Come on in, guys. Relax. I'm recording this, so I want to finish this. Unless you guys want to come up here and do this for them. Yeah, you want to talk about gravel? It's this minus 100, and all we got to know is if it's positive or negative. And it's negative 1.859. What are the units on that? Tons per hour. Thank you, Louise. There you go. Since that's negative, we're going to write a little sentence here. Look at this. Oh my gosh. What's it say? The amount of gravel, right? The amount of unprocessed gravel is decreasing. Great. Nope. The amount of unprocessed gravel is decreasing at t equals 5 hours since we labeled what A was, crap, you can just say it's less than 0. A lot of y'all are saying A prime of t is less than 0 at 5 or something like that. Just say A prime of 5 is less than 0. Okay? Or negative. Same thing. Simple enough? Yeah. Yeah, so you also, wait, find G of 5 and what? An L of 5, you called it? 100, okay. Yeah, guys, you could also find G of 5 and show that it's less than 100, which means less is coming in than is going out. You can go that route as well, okay? But the whole point of the amount thing is now once we have that, we can answer part D really easily too, okay? We'll find out where D says the max amount, right, from 0 to 8. Cool, I told you, there's 3 things you do for that. Number 1, when is the rate of change if it's 0? We're looking for the critical numbers. Okay? On your calculator, you're going to graph that. So I'm going to subtract off 100, and I'm just graphing the derivative. I'm going to see where it equals 100 between 0 and 8. So I'm going to go to my window. I'm going to graph from 0 to 8. And I'm going to see what this thing looks like. This is my favorite graph ever, by the way. It's not graphing. What's wrong? There it is. See how there's only one critical value? Okay, is that a max or a min? Definitely a max. Okay, because the derivative is going from positive to negative. So we're going to hit second, trace. What do we want? The 0, right? That'll work. And it looks like it's somewhere around 1, 2, 3, 4, 5. So I'm going to say look between 4 and 6 and guess 5. And we get, what is that, 4.923? Did you guys get that? Okay, and I'm going to store that number as B. I'm not going to use A because I already used A for my amount function. Okay, but we get 4.9234, which I'm going to write equals B. That's the only one, and then I'm going to find the amount at the endpoints and at the critical values. That's the second step to this. Okay, we know this one's already 500 tons. To find the others, we got to do our little function. What was it? 500 plus math 9 from 0 to, what are we doing? 8 of my derivative function, which was this. Yo, is everybody with me here? That's the amount at 8. I put the minus 100 on my y1, okay? Yeah, but yeah, if y1 was just g, then I put a minus 100 in that integral as well. And then we're going to do the same thing, just real quick, except I'm going to integrate to b, alpha b. So we get, and we're expecting it to be bigger, 635.376. Oops, 6 tons. And what was 8? Oh, that's right here. 551. 525.551 tons. Okay. I've done this a bunch of times. I keep telling y'all, some of y'all are not doing this at all. You're going to write a little sentence now. The maximum amount is 635 It didn't say round to the nearest ton, did it? Okay. Is that many tons at T equals, and you can just type it out or just put B, 234 hours. I checked the endpoints and where A prime of T changes from positive to negative. There you go. Ta-da. Full credit, 9 points, 5 calculus credit, going on with your life. Things are good. All right.